seems to be a kind of convergence of many ideas and people that met and methods at this, more or less at the same time in this end of the 60s, during the 70s. So we can think of Arnold, Gromov, Elie Ashberg, in the United States, Alan Weinstein, Thurston. So people and methods were ready to found, in some sense, symplectic geometry, isn't it? And how did you benefit from that convergence?
You know, I was aware of some of the debates because at MIT, when I was there, Bill Thurston was just there and people were still trying to understand his ideas. And then I spent some time in Princeton afterwards, and he was there doing a lot of hyperbolic geometry, but still always alive with lots of geometric questions. And people were trying to solve elementary questions about contact geometry. So I was more aware of that, the sort of the geometric side of the questions at that time. But there were also Alan Weinstein. I mean, there were people interested in periodic orbits, trying to find periodic orbits for Hamiltonian flows. And there were new advances in critical point theory and convex geometry that led people to find new methods of proving the existence of critical points. So that was something completely out of what I knew, but it did really come together. I would say the main influence at the beginning of the 70s, that there were these developments as a proof of the Arnold conjecture by Conley and Zander, and then Gromov's paper about J-holomorphic curves, which in some sense, certainly for me, came out of left field. This was a totally new idea. I think it was a completely new idea, but it had something to say. So, and then, well, Fleur sort of put things together. I mean, the variational point of view together with this complex geometry, and really, in retrospect, I mean, that was an incredibly important formulation of ideas in symplectic geometry that's led very far. And there were many people who contributed. Viterbo contributed. He proved that there were several conjectures that people had, which seemed rather innocent. Like if you have a hypersurface in Euclidean, an even-dimensional Euclidean space, does it have a closed periodic orbit? That's one question. And the other one was the existence of fixed points of symplectomorphisms. They were sort of motivating questions at that time, and people devised brilliant ideas to try and solve them.
One needs many prerequisites. So one needs to understand algebraic geometry, algebraic topology, analysis, and topology and geometry, of course. So PDEs, so many things. And so the subject is out of reach for many people because it requires so much knowledge of mathematics. I think that you had exactly the right knowledge at that moment to enter the field.
Well, you know, the many things I was completely ignorant of, and so I was learning as I went along. So, for example, I knew no algebraic geometry. I knew very little of four-dimensional topology. So when I proved this result about rational and ruled manifolds, I only learnt what those words were after I proved the result, so to speak. You know, I mean, I've always felt I've had a great lack of background, that I just haven't known things. I have learnt subsequently that many people feel that way.